The FurseWELD Exothermic Welding process is a simple and portable method of welding copper to copper or copper to steel. During the video, we'll show you how to make an effective joint, tell you what equipment you'll need, and summarize the main safety issues. Please bear in mind that this system is not suitable for connecting aluminium conductor, and that for this, standard mechanical connections would need to be used. There are several advantages to the FurseWELD system. For a start, it requires no outside power source, so it's totally portable, which makes it very quick and easy to use. It can be used to weld a variety of metals, including galvanized surfaces, as long as any paint is removed. And what's more, the FurseWELD system will save you money, particularly on materials. The connection produced is a fusion of virtually pure copper, and in most cases has twice the cross-sectional area of the conductor being welded. This means that the joint is superior to standard connections, and it's permanent. This welding process allows the earth conductors to carry fault currents at higher temperatures, which ultimately means using a smaller cross-sectional area of conductor for a given fault current. FurseWELD connections utilize the high-temperature reaction of powdered copper oxide and aluminium. Mixed and ignited, these produce an aluminium oxide slag, a molten copper. As with any kind of welding, there are potential hazards. We recommend that you wear gloves, eye protection, boots and a helmet, which comply with normal site regulations. The FurseWELD equipment itself consists of a specially designed and clearly labeled graphite mould, handle clamp, FurseWELD powders and discs, flint gun and cleaning tools. Each joint type and configuration has its own specific mould design. To make an effective joint, it's essential that you do some preparation before you start. The surfaces of all the conductors to be welded must be clean, dry and bright. Any oil, grease and moisture can be burned out with a butane or acetylene torch. After cleaning, use a cable brush or file card to get rid of any residue and to brighten the surface. The graphite mould is made up of a crucible, tap hole and weld cavity. The reaction takes place in the crucible, and the tap hole directs the molten copper into the weld cavity, which houses the conductors that are to be joined. In most cases, the graphite mould is split to allow it to be clamped around the clean conductor, which you do by using the handle clamps. If the mould doesn't close properly, you can adjust the tension by removing the split pin and turning the eye bolt. Do not use the mould to try and straighten bent conductors. The mould itself must be dry, so you'll need to preheat it to make sure that the moisture is expelled. Then you can position the conductors in the mould. The leaflet enclosed with each mould will tell exactly how they should be positioned. Once the conductors are in place, a small steel disc contained in the powder box is inserted into the mould crucible. Make sure you have it centered over the tap hole. This will prevent the powder from dropping through the mould. You can get 4 different types of powder, which relate to the type of connection being made. Further details on the powders are in the FurseWELD leaflet. The type, size and quantity of powder is marked on the plastic container. The size is also marked on the end of each tube. Pour the welding powder into the crucible. You'll find that the starting powder will be retained in the base of the cartridge, so loosen it by tapping. Spread the starting powder evenly over the welding powder, placing a small amount on the top edge of the mould for early ignition. Then close the cover and ignite the starting powder with the flint gun. The instantaneous reaction produces molten copper, which melts the steel disc and runs into the weld cavity. The steel disc with other impurities is converted to slag. You should wait just a few seconds until the slag goes from dull red to black before opening the mould. This will indicate that the metal has solidified. Graphite moulds have an average life of about 75 joints, depending on how they're looked after. Obviously, cleaning the mould will prolong its life, so remove all slag and dust before making the next weld. Remember, the mould and conductor will be hot, so handle it carefully. To clean it, you should remove the slag with a scraper and fine clean it with a brush. Don't use tools like wire brushes, as these will damage the mould. The joint that's just been made is a BB14 bar-to-bar joint and is relevant to primary substation applications. A BS1 type joint, bar-to-steel surface, is used to connect the main earth conductor to the main transformer, the neutral earth resistor and fencing. You'll need a 50mm by 50mm section of steel to make an effective joint. Again, you should make sure the surfaces are clean, and any paint or rust should be removed with a grinding wheel, followed by brushing. Zinc-coated steel is all right as long as the surface is flat and oxide-free. You can use a wire brush to remove the oxide. The mould should be held in position by a G-clamp. The other joints relating to primary substation work are the bar-to-rod joints BR1 and BR2. It should be remembered that where earth rods are to be welded, the top threaded area of the earth rod should be removed using a hacksaw, as the mould needs a smooth surface to ensure an effective joint. Grips should be used to make sure that the mould stays in place. For secondary substation and pole-mounted transformer earth nests, the CC1 cable-to-cable straight-through joint and CR2 and CR1 cable-to-rod joints can be used. Although these are the main joints you're likely to use, a wide selection is available for a variety of applications. Special moulds can be prepared to help solve any installation problem. To recap, here are the main points that you should bear in mind when using the FurseWELD Exothermic Welding System. Always wear protective boots, gloves, goggles and helmet. The production of an effective FurseWELD joint requires the right preparation. Surfaces should always be thoroughly cleaned as demonstrated. Ensure that all conductors and the mould itself are dry. And finally, after each use, make sure that the mould is carefully cleaned. Full details on the FurseWELD procedure for each type of mould and conductor are set out in the leaflet that comes with every mould. The FurseWELD Exothermic Welding System and copper bond rods provide excellent joints with superior corrosion resistance properties and save you money on materials. FurseWELD Exothermic Welding for cost-effective joints.